Thank you for joining. I'm Chris. I work for roughly a year for VW. Previously, I was working as a software developer for a supplier for VW, and I have a lot of background in speech recognition, designing all the systems in the car right now you can buy. And with that in mind, I joined the lab last year, and I was asking myself, can we actually do something in VW? Meaning, can we implement a speech recognizer on our own? And if so, what are the hassles and what is the effort we have to do so? So I was part of a team, roughly 4 or 5 people, and we did a 6 weeks sprints, and we tried to basically use data in order to get an end-to-end speech recognition, meaning from the pipeline, having the data, doing supervised learning, and having the transcription after that. So if you take Siri as an example, speech recognition is only the first part of doing stuff, right? So if I say an utterance, this is speech on the upper left, it will get transcribed to text saying whatever, I don't know, play me some rock music, right? And this text has to get processed through an NLU component. Meaning, if I say play me some rock music, I need then to find the intent, namely, for instance, play music, and also find the slots. Rock music would be the slot. Right? Then I need a dialog manager that is a component that can take the utterance and identify if everything I said is complete to take the action. Meaning, if I say play music, for instance, maybe the dialog manager would ask what kind of music, right? And after the dialog manager, we have the natural language generation part, where we want to generate the answer. Like, your music is playing. Okay, so at the end, this your music is playing answer gets synthesized in text-to-speech, and the circle closes. So we focused in our effort only for doing the speech recognition part, right? Okay. So what is speech recognition? I like to see things simple. And for me, speech recognition is just a function that gets an input. In this example is this input utterance, this blue wave file, and producing a transcription of the utterance said. For instance, hello world. So what we want to do is to find this function f. And for doing so, we are going to use the data. So in the team, we tried to establish some goals. So the first one was like doing an MVP software for speech recognition, so nothing Siri killing like or Google Assistant killing like, but roughly having an understanding of what is the technology behind, what do we have to do this on our own. We wanted to achieve a 5% character error rate on the test set, meaning 5 characters out of 100 can be wrong, not more, not less, or more, not more, but it's okay if it's less. The software we wanted to implement should be deployable offline and cloud-based. And we limited our vocabulary in recognizing 100 sentences for use cases like trip control, music selection and light. So the approach we used was like having a balanced team. So I was part of 3 developers. We had a designer, a UX designer in the team, a product manager who was talking to the product owner, and we did extreme programming, pair programming, and test-driven development for doing this. And we used the paper written by the Baidu guys in Silicon Valley called Deep Speech 2 as a foundation in order to get our speech recognizer running. So let me describe a little bit how things work. So maybe first, who is actually aware of machine learning here? Okay, nice. Who has trained ever a neural network? Okay, cool. Who has done speech recognition before? Okay. So I will be not that technical for these guys who have done speech recognition, but if you want, you can interrupt me and I will dive in to questions. So what we first did was, our designer was like, we have to be user-centric, right? So we have to interview potential candidates, potential users, and find out what are the utterances they are going to use to play music, to have trip control and lighting. So she did a lot of interviews, and we come up with the best 100 sentences people say if they want to use their voice assistants for navigation and music and lighting. Then we implemented a tool, the speech recording, that candidates we recruited used to donate their voice, right? So we talked to an agency and we asked them, can you bring 1,000 people of around Europe with English accent or English foreign as a language, and then we said we want them to be 50-50 men and women, the age, and what else? Nationality. So we have much the broader European language modeling, and they use this tool on the left to record our sentences. So this was roughly 1.5 million samples, roughly speaking. And then we collected all of this data, and it was already annotated. So I don't know if you can see this, but on the right, on the red box here, we have already the text people have to speak. So we use this already as a label for the supervised learning. So we had already the labeling. But then the question raised, do we trust the data? Meaning, of course, we trust that people spoke and did what we wanted them to do, but can we use this data without checking it, without having some quality control, some metrics? So for the first run, we did we trained a model, and it was very, very bad. So we had a lot of bias. So we were thinking then, okay, we have to somehow get messy and maybe clean the data set. So then we got the pre-processing stage, and for this we used the Mozilla Deep Speech effort. This RSR is Mozilla's deep speech engine, so it's this already deployed speech recognizer, and we asked ourselves, if this guy can do the transcription, then the sample is good. If the deep speech Mozilla ISR cannot do the transcription as well, meaning the edit distance is above 3 or 4. Edit distance is the metrics we use for string similarity, so meaning what is the minimum amount of operations I have to apply in operations in terms of insertion, deletion, and substitution of a character to transform one word to another. That's the metrics we use, right? So edit distance above 3 means we have 3 operations to transform both words, which would be not good. Everything below 3 was okay, so we took it as a validated sample. So for the else path, if the Mozilla recognizer couldn't transcribe the words, we used a manual written application where our colleagues here from the whole lab would validate this manually. So people would hear a sentence and then they would say, oh, this is volume up, or no, this is not volume up. After doing the validation, we splitted the data set in trained and test, trained the acoustic model, computed the character error rate, and then we had a model zoo where we just picked up the best one and deployed. So this is, roughly speaking, the pipeline. So one would ask, okay, if the training part is done automatically, what was basically our part? So we wrote this training data ourselves, but the most time-consuming part was the speech data set. So basically maintaining this infrastructure, finding a common understanding about what is a good word, right? So you will see in a minute, people have very different meaning about what is a good word. And then you find the interesting data to label, and then, of course, cleaning the data. Because we had many people that didn't speak at all, they just left their TV station on, and you were hearing like the news, or you were hearing like people laughing. So this was everything we had to clean. So I want to give you an example of how manual labeling works. So we will do it like this. You will hear something in a minute, right? And then I want you to try to understand what you are hearing. I will then show what is the correct answer, and then we will see how many people got this right. Is it the deal? Okay. So, I hope that we're going to hear something. Let's see.
We have to plug it in.
Ah, HDMI?
I can do it. His eye is not able to do it.
I thought we had. What is this? Nerve is low. So, tension.
Place and wake up.
Did you hear something?
No.
One more time. So this would be cheating, right? So the network would only have once this chance to hear something. So we already cheat here. So be quiet, please.
Place and wake up.
Okay, so this is the correct answer. Who got it right? So interesting. So we would discard this because it's below 50%. So I wouldn't take this sample for training the neural network. So I will take the second part, the second sample. Take a listen.
Please keep this on.
Got it? Who got this right? I think we would take this. So the first thing would be, can I understand the utterance as a human does without seeing the sentence at all, right? So as you perceive me right now speaking, but then you have some other questions to answer. I will come to this in a minute. So I wanted to show you how to label stuff, but there is more. Before doing this, I wanted to show you our albino monster. So we use this machine to train the network. It's a gaming PC with two GTX 1080 Ti's, so it's not a rack server or whatever. We could train a model within a day. And we use both GPUs separately for doing experiments. So you will end up having parameterization, optimization. You will do lots of experiments. So we use not both graphics cards for a whole model, rather we use one of them for every experiment. So we had luck in terms of the cooling, so our dev office ops guy said we need water cooling because if this guy works 24/7, you will get some issues. So we had roughly 45 degrees Celsius all the time, and this was due to the cooling we had. So I want to wrap up with some lessons learned, and I will come back to this labeling stuff. So the first thing we learned the hard way was, can we trust the data, right? So and the answer is completely no. You get data, but then you have to do the dirty work. So it isn't fun to manually validate 120,000 samples. And it's a job that is not motivating, and you have to be sufficient with your data, meaning it's enough. I have the whole world I want to recognize, like German-speaking people with English as a foreign language. And unbiased meaning, in Berlin there is not only German, So you need to have something else. Then what is the quality metric? So you could now maybe label what I said, what I played previously, but what if someone, right, what if someone, exactly, or if you have something in the background falling at the end of the sentence, right, like a noise. Is this something you want to take in your data set? Or what is if people are singing? They are not actually speaking like they do. What is the quality? How can you find rules that anyone can apply in your team to come up with, yes, I want to take this sample, or no, I don't want this. This is a very, very tough point. And then the algorithms question. So can we trust the algorithms, meaning this deep neural network we use? And I didn't mention this because I don't want to be very technical, but for the people here in the room who want to know, so we use a spectrogram of the audio sample. It's a 180 dimensional vector. We fed it through the two convolutional layers, right? And then we fed it through a recurrent neural network, 3 or 4 layers. And then we had the softmax at the end, and we classified into one of the 26, 27 characters. So we classified from audio through convnet, through an RNN-net onto characters. So invariance is one question, meaning what happens if I have a speech that has background noise in the car, for instance. Is my function invariant enough to recognize me saying play some music in the car? And the stability issue, meaning you maybe have heard this, adversarial attacks are very popular right now. People can change the outcome of a network by just adding some noise, and the same holds true also for speech recognition. So I can guarantee you that this approach isn't stable. So these are the lessons we learned the hard way, and also for the software engineering part. So there is no IDE for machine learning. You cannot debug like doing a breakpoint. And because you just write code through your data set. This is something not done many times, you know. So right now you write your code, you know what you're doing. Doing machine learning means you use data to let someone else write your code. And you don't know how this code looks like. In code in terms of the weights, right? Labeling is an iterative process because once you got the first sample that you didn't come up with, you will have to refresh your ruling, and then you have to teach your labelers. Basically, we start all over again because you don't know how much of the data you maybe missed labeling correct. And then you have at the end to deal with data imbalances. For instance, we had the words like volume up or volume down for doing the music loudness. These were very, very little in terms of samples compared to other words or sentences, mainly because there were too many faulty words in them. So we discarded them, and this was a very, very small sample data corresponding to not getting correct recognized in terms of accuracy. Finding this and then resolving this is also nothing easy to do. So I hope you had some fun, and thank you for listening.